If you keep hearing a lot about Snowflake in the data engineering world and you want to understand what this hype is all about, this video is for you. I am CS and you are watching the Snowflake Learning Series of 2026 on Data Stack, where we go from I have heard about this tool to I can actually use in real projects. Over the next several videos, I'm going to take you on a journey from absolute beginner to advanced Snowflake user. And the best part is we are going to learn this together. I'm documenting my entire learning process so you get to see how I approach learning new technologies as a data engineer. Today we are starting with the fundamentals, understanding what Snowflake actually is and how it is different than the other warehousing solution, how its architecture works, and by the end of this video you'll understand why Snowflake is one of the largest used data warehousing solution and why so many companies are migrating to it. Let's dive in. So what exactly is Snowflake? Snowflake is a cloud-native data platform that brings together data storage, processing, and analytics all in one place. Think of it as a complete data warehouse solution that runs entirely in cloud. Now here is what makes this really special. Snowflake is delivered as self-managed service. Now what does that mean? Number 1. There is no virtual or physical hardware for you to select, install, configure, or manage. Number 2. There is virtually no software for you to install, configure, or manage. Number 3. Any ongoing maintenance, management, upgrades, and tuning, all of these will be handled by Snowflake automatically. Now, if you have worked with traditional databases like SQL Server or Oracle, you know how much time goes into hardware provisioning, or capacity planning, software patches, and performance tuning. With Snowflake, all of that just disappears. Now, Snowflake runs on top public cloud like AWS, Microsoft Azure, or GCP. But here is the key point. We cannot install Snowflake on premises or any of our private cloud, and it is totally by design. Now let's talk about why this architecture is so amazing. To understand what makes Snowflake special, we need to talk about two traditional database architectures. Historically, databases fell into two categories. First is shared disk architecture. Here what happens is multiple compute nodes access the same storage that you can see here in the diagram. Think of it like multiple people are trying to read from the same hard drive simultaneously. Now there is some advantages to it. The most important one is the easy data management. Everyone sees the same data. You don't need to maintain different databases. You have to just maintain one database for everyone. Now there are downsides to it. The most important one is the performance bottlenecks, because everyone is fighting to access the same storage. Now let's talk about the second architecture, shared nothing architecture. Here is each compute node has its own storage. The advantages are massive parallel processing. Each node works independently. Now there is a downside to it too. This makes the data distribution complex because you have to maintain multiple databases for each of the compute nodes. Now here is where Snowflake breaks the mold. Snowflake uses a hybrid architecture that takes the best of both worlds. Let me show you the official architecture diagram from Snowflake documentation. Now if you look at the architecture, the data management simplicity comes from the shared disk architecture, with the performance and scale out benefits from the shared nothing architecture. How Snowflake does this? Through three distinct layers that works together. Let's break them down. Snowflake's architecture consists of three layers. I'm going to walk you through each one with examples. The first layer is the database storage layer. This is where all your data lives. When you load data into Snowflake, something interesting happens. Snowflake doesn't just store your data as it is. If you look at this example, first the raw CSV file is getting converted into Snowflake's optimized format. It recognizes your data into its own internally optimized, compressed, and columnar format. Then it stores this into a cloud storage like Amazon S3, Azure Blob, or Google Cloud Storage. Now Snowflake handles three types of data. One is the structured data, your traditional rows and columns in tables like a customer database you can say. Second is semi-structured data like JSON, XML, Parquet files, that data which has flexible schemas. And the third is the unstructured data like documents, images, and audio files. Now here is a crucial concept, micro-partitions. Snowflake automatically divides all your data into what they call micro-partitions. These are units of storage, typically from 5 to 500 MB of uncompressed data. You don't manually create these. Snowflake handles this automatically. This is key for performance because Snowflake can skip entire micro-partitions when running queries, a technique called pruning. We'll talk about this in our next videos. Snowflake also manages everything else like organization, file size, compression, metadata, statistics. You literally never think about any of this in Snowflake. Now the second layer is the compute layer. And this is where the magic happens. In Snowflake, compute is handled by what they call virtual warehouses. A virtual warehouse is essentially a cluster of compute resources. Think of it as a collection of servers working together to process your queries. Here are the critical things to understand. First, each virtual warehouse is completely independent. If I am running a complex analytic query on warehouse A, it has zero impact on your simple select query running on warehouse B. This is a complete isolation. Second, you can have multiple warehouses running simultaneously. You might have one warehouse for your finance team, another for marketing, another for data science, all running at the same time, not affecting each other. And the third, you can resize warehouse on the fly. Start with a small warehouse. If you need more power, scale it up to large or extra large. If you don't need it, you can scale it back down or suspend it completely. And here is the beautiful part. You only pay for what you use. If your warehouse is suspended, you are not paying for the compute. You are just paying for the storage here. This is the separation of storage and compute that everyone's talk about with Snowflake. Your data is always there in storage, but compute spins up only when you use it. Now let's talk about the third layer. The third layer is the cloud service layer. This is Snowflake's brain. This layer coordinates everything across Snowflake. From the moment you sign in to the moment your query result appears, cloud service are managing it all. Let me break down what runs in this layer. First is security and authentication. Things like user authentication, access control, role-based permissions, multi-factor authentication. All of this is handled in this particular layer. Second is management. In this layer, it coordinates with AWS, Azure or GCP. It manages the virtual warehouses, resources, also auto-scaling and auto-suspend of the warehouses. Third is metadata management. The information about your databases, tables, columns, query histories, all of these are stored over here. Fourth is query optimization. In this particular layer, it parses your SQL query, create optimal execution plans, and query completions and optimization. Now there is an important thing to notice here. These cloud service also runs on compute instances, but they are provisioned and managed by Snowflake only, not by you. Most of these services are included in your cost with no additional charges. Now let me show you how these three layers work together with a real example. Let's walk through a complete example to see how these three layers interact. Right now we are in Snowsite. This is the Snowflake's web interface. We are going to talk more about this in our next lecture. And here we are writing a query. Select star from customer where country equals to India. The query hits the cloud service layer first. It authenticates you, checks if you have the permission to access the table, parses your SQL query and creates an optimized execution plan. Now next, the cloud service layer checks the metadata. Where are the micro-partitions of this particular table? Which one contains the data for India? Next, your virtual warehouse spins up if it is suspended and start processing. Because of micro-partition pruning, it only reads the partition containing Indian customer data, not the entire table. After that, the compute nodes pull the necessary micro-partitions from storage, maybe from Amazon S3 or ADLS. Now the virtual warehouses process this data in parallel across multiple nodes and return you the result. To summarize this, storage layer holds the data, compute layer processes the query, cloud services orchestrate everything. All three layers working in perfect harmony, and you just see your results in seconds. What you did is wrote a SQL query. What Snowflake did is authenticated you, optimized your query, pruned irrelevant data, processed in parallel, cached the results, returned the data. This is the power of Snowflake's architecture. Now that you understand the architecture, let's talk about why it matters for you as a data engineer or analyst. Benefit number 1. No hardware to buy, configure or maintain. No capacity planning headaches. No worrying about disk space or server crashes. Snowflake handles it all. Benefit number 2. If you need more compute power, scale up in second. If you don't need it, scale down or suspend it. Benefit 3. You only pay for the compute that you are using and the storage you consume. If your warehouse is suspended, there is no compute resources or charges for it. This is completely different from traditional licensing models. Benefit number 4. Micro-partitions, automatic clustering, result caching, metadata optimization. All of these handles automatically. You don't need to even do any manual indexing. Benefit number 5. Different teams can run different workloads simultaneously with zero interference. Your ETL jobs don't slow down your analyst dashboards. Benefit number 6. You can choose your cloud provider. If you're not happy with that, you can even replicate data across clouds. This is a true cloud agnostic architecture. Now let me give you a real world scenario. So let's consider it's a month end. Your finance team needs to run a massive report. Normally this would slow down everyone else. With Snowflake, you create a dedicated extra large warehouse for finance. They will run their reports on this and it will be totally isolated from everyone else. Now once the report is completed, they will suspend the warehouse. Let's say we have used it for 2 hours, right? Then you are going to pay only for 2 hours. Alright, so now you have understood Snowflake's architecture. You know what the three layers are: storage, compute and cloud services. You understand why separations of storage and compute is powerful. But understanding architecture is just the beginning. In the upcoming videos, we are going to get hands-on. We will set up our free Snowflake trial account. We'll give a complete tour of Snowsite, the web interface of Snowflake. Then we are going to create our first virtual warehouse. We are building from fundamentals to advanced topics, and I am documenting every step. All the information in today's video came from Snowflake's official documentation, which I have linked in the description below. I highly recommend bookmarking it. Here is my advice. After watching this video, go to the documentation page and read it yourself. See how I translate the docs into this tutorial. This is exactly how I am learning. I read the docs, understand them, then I create content to reinforce my learning. If you found this video helpful, please hit the like button. It really helps the algorithm show this to other people who is learning Snowflake. And definitely subscribe because I am trying to release new Snowflake tutorials every week. I am committed to this journey and I want you to join me. Thanks for watching and I'll see you in the next one. Until then, keep learning.